Another topic is called linear factors theorem and conjugate zeros theorem. So we're putting two theorems together to solve these type of problems in ALEKS this week. So it says, suppose that R of x is a polynomial with degree 12. Oh my goodness, degree 12. So how many zeros will this polynomial have? 12 zeros, okay? It's gonna have 12 zeros, but don't worry, we don't have to find them all. But whose coefficients are real numbers? Also, suppose that R of x has the following zeros. Ooh, they gave us 1, 2, 3 zeros already. So we just don't know 9 of the other ones, right? But first one is a real zero. This one, this right here, is a non-real zero, right? So if 2 plus 5i is a 0, guess what? 2 minus 5i must be another 0 because by the conjugate zeros theorem. Because non-real zeros always come in pairs with this conjugate partner, okay? Not only that, look at this last one. You have negative 2i, right? So another 0 would be positive 2i. I think in ALEKS though, they just want you to find another 0. So if you type either of them, you will be fine. I don't think they want you to type both of them, okay? But hey, even though they just 3 zeros to begin this problem, I know 1, 2, 3, 4, 5 of them already, okay? Now, B is asking, what is the maximum number of real zeros R of x can have? And this is how I do this. So I'll show you what's going on in my head, okay? So there are 12 zeros, right? So this is what I'm about to do. 1, 2, 3, 4, 5, 6, hang in there, 7, 8, 9, 10, 11, 12. So what I did, I drew 12 blanks, okay? 12 blanks because we are gonna have 12 zeros in total, okay? Now I'm gonna identify them or I'm gonna classify them as real or non-real, okay? So first one, 5, what they gave me, that's a real number, right? 5 is a real number, so I'll put capital R to abbreviate that real number, okay? Next number they gave me is non-real, right? Well, how do I, okay, I'll say non-real, non-real, okay? But if 2 plus 5i is a 0, well, we know 2 minus 5i is also 0, right? So we have two non-real zeros here. So I'll write little n for non-real, okay? Non-real, non-real. 2 oranges, you see? The third one they gave me was also non-real, right? This one was non-real. But its conjugate partner must also be non-real. So how many n's do I get from this green pair? 2, right? Non-real and non-real. You know what? That's the given, and that given is not going to change. I'm just gonna quickly copy this. Okay, give me 1 second. I'm gonna copy this down for the next part because we're gonna use that same given. Nothing changes. But here, what they want is how many real zeros, the maximum number of real zeros can X have. So what we're going to do is we're gonna fill out the rest of them as real because there's no condition to be a real 0, okay? It doesn't have to come in pairs. So look at what I'm doing. I'm going to fill out the rest of them in as real. R everywhere. Let's put R everywhere, okay? Now let's count. How many real zeros can R of x have? I count 1, 2, 3, 4, 5, 6, 7, 8. So 8 real zeros is the answer. It can have a maximum of 8 real zeros, but it's not going to be 9 or 10. It's going to be 8. Real zeros, I think, is the easy one because you can fill out all the rest of the blank is R with no restriction, okay? But non-real, we gotta be careful because remember, these always come in pairs. So make a note of that. Non-real zeros always in pairs. Take a look. So I'm gonna write N here. But if I write 1n, its partner has to be a 0. So I wrote, and I'm going to try to like group them. See, there's a pair, there's a conjugate pair, there's a conjugate pair. Okay, I have 3 couples here, okay? Only couples of non-real zeros are allowed. Next, I can have non-real 0 here, and I can have non-real 0 here. And these are couples, so that's okay. They're happy, okay? Let's see if I can accommodate any more couples. Oh, non-real 0 here, non-real 0, its partner right there. And see, I can do a couple here. All right, last one. I'm going to put an N here. Can I put an N there? Nope, 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 right? See, if I put an N here, this guy right there, that non-real will not have a room for its conjugate partner. So that last one cannot be a non-real 0 because we don't have a 14th or 13th blank to have its conjugate pair coming in. So the last one's gotta be real, unfortunately, okay? Because you can only have even number of non-real zeros. So let's count how many non-real zeros we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we can have 10 non-real zeros. That's how I see this, okay? But I don't know, maybe there are like different ways to explain this problem, but you guys try this topic. I love putting this one on your second test. So practice this topic this week and let me know if you want to talk more about this, okay?